One thing that people use computers for is to model biological systems, and today we're going to do a project that does that. So I have an idea. My idea is that there are a bunch of green dots, and think of green dots kind of like plants. So when a green dot shows up, I'm going to go ahead and run this program to show you what it does. It gives instructions, and when you click on a green dot shows up, and green dots grow. So you'll see this green dot get bigger and bigger and bigger. Eventually they get so big that they in fact multiply, that a new green dot will show up. So think of this as a biological system and think of green dots kind of like plants. So the plant starts out small, and then as it grows over time, maybe it's through wind dispersal or something like that, it creates a new version of itself, and it just keeps growing forever and ever and ever. Unless a predator comes along. Predators are the red dots. Now they actually can move, and the rule with a predator is that if it hits a green dot, it kills the green dot, and it creates a new version of itself, a new red dot. So here's our first red dot. It's going to zoom around for a while. If it doesn't find food, it's going to die, and this one is about to die. There, it died because it didn't find any food. Let's try another one. Here he goes. He's moving around, and whoa, he just found food. And you can see that every time the red dot hits a green dot, it makes another version of itself, and it dies eventually because it didn't find enough food. But you can imagine what would happen if I put in a whole bunch of red dots. It would eat all the green dots, and then all the red dots would disappear too. All the red dots would disappear as well. So let's see what happens when I add a whole bunch of red dots. It's going to eat all the food, and then everything's going to die. So here's a bunch of red dots. And now all the green dots are gone, so no more food is available, and the red dots are going to die out. This is how a biological system might be modeled. If I create more red dots, again, they're going to die out because there's no food for them. If I create more green dots, suddenly there is a lot of food, and so now the red dots will multiply. Problem is that they may outstrip their food supply, because they multiply every time they hit a green dot, and the green dot dies. So you can see how the red dots are now more numerous than the green dots. And I think our biological system will collapse. There's only one green dot left. Oh no, all the green dots are gone. And so they're all going to die out. So now let me show you what the code is for this program. It uses something called cloning. Cloning is a pretty important concept because it is an example of object-oriented code. Object-oriented code is when you have one object that you program, but you can actually recreate that object multiple times. So you don't have to say, hey, I want to create 50 different versions of red dude or green dude. You just say make a clone. So first let's start with the most basic part of the program, which is the instructions. So when the green flag is clicked, this guy is going to give the instructions. This is a biological system that shows you how cloning works. The green dudes grow and they multiply as well. The red dudes zoom around and eat the green dudes. They multiply only if they eat a green dude. Click on the plus buttons to add more red or green. So now let's see what the plus buttons do. The plus green button, when I am clicked, create a clone of green dude. That's all he does. When red button is clicked, when I am clicked, create a clone of red dude. Now let's see what green dude does. When this is clicked, please go to x equals 5,000 and y equals 0, which is way off the stage. It's way over, out of sight. The reason is I don't want a bunch of green dudes running around, and you have to have at least one green dude to make this work. But I don't want him on the stage, so I set him to 5,000 and y equals 0. When I start as a clone, set size to 100%. That's actually going to be small. And then use a function called goRandom, which is a function I created. Let's see what goRandom does. I'm going to hold down the control button and say edit this block. goRandom just picks a random location of -150 to 150 and y -150 to 150. So when I start as a clone, set my size to my small little self, go to a random location, and then forever wait 1 second, change size by 5. So grow bigger and bigger and bigger every second. Another thing I want to do is when I start as a clone, forever see if one of the red dudes is touching me. If a red dude is ever touching me, kill myself. And then also when I start as a clone, wait 15 seconds and create a clone of myself. So if I actually live for 15 seconds without getting eaten, then I'm going to create another clone of myself. Now you may ask yourself, why do I have all these different hat control things? It turns out that if you have too many commands underneath a hat, it gets a little bit confused. So this is called a control hat. So I actually break it up into little pieces like this. But this is what the green guy does. So let's just make sure this all works. Here we go. I'm going to create a green guy. So he shows up, and when I start as a clone, set size to 100, go to a random location. That's my random location. Forever, wait 1 second, and then change size by 5. So you can see that he's growing. After 15 seconds, create a new version of myself. There's the new version of myself, and you can see that he was small, the original size. And after 15 seconds, he's going to clone himself. Okay, and we're going to get another green. There's my another green. So as we have greens, they keep both getting larger, and then eventually they reproduce, just one time. So we're going to end up with 3 greens, and then 4 greens, and then 5 greens. Now let's take a look at what the functions are for red dude. Red dude, when I start as a clone, go to a random location, pick a random degree, and then repeat this 500 times, which is move 2 steps. If I'm ever on the edge, bounce, and then after I've moved 500 times, delete this clone. But when I start as a clone, forever, if I'm touching a green dude, wait until I'm not touching the green dude anymore, and then create a clone of myself. If I don't have this line here, wait until not touching green dude, then it will create a whole bunch of red dudes. I want it to just create basically one red dude every time it hits a green dude. And again, when the flag is clicked, please make the original sprite disappear. If you look at the green sprite, it sent it to 5,000 and 0. The red dude is sent to 1,000 and 0. I was having problems, and then I realized that I was sending them to the same place, and it was messing up the code. So I had to send them to different places. But now I've got these green dudes, and some of them are quite big, as you can see. Let's see what happens when I click on a red dude. So the first thing is he shows up, he moves, and because there were all those green dudes around, he just started going crazy and eating them all. And quickly, he decimated the entire population of green dudes. So let's introduce a few more green dudes, and let's throw in a red dude, just one, and see if I can create a sustaining population. So these red dudes, maybe they're a little bit too aggressive. Maybe they move too fast. So I'm actually going to change my red code a little bit. Instead of having it move 2 steps, I'm going to only have it move 1 step. It's going to go slower now. And now let's see what happens. So I'm going to, oh yeah, it's going to give me the instructions again. Blah, 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 blah. But I'm going to hit some green dudes, have some green dudes show up. Okay, I've got about 15 of them. And now my red dudes are going to go slower than before, which means they're going to be a little bit less aggressive in terms of eating the green dudes. So they may die out a little bit more. I'm trying to create a sustainable system. Throw in a few more red dudes. And you can see how, like a biologist who's looking at a wolf population versus mice or something like that, studying a biological system, could actually create a program to do it. They might think a little bit more about how the plants grow and reproduce and things like that. But you've got the basic idea here, and it uses this idea of cloning. And the important thing here is that cloning is an example of object-oriented code. I don't have to actually create different green dudes. I only have one green dude, but he clones himself. That's the power of object-oriented programming. Same with the red dude. I only have one red dude, but he clones himself at various times. So that is an example of using a biological system or creating a biological system. I call it assignment 5 here, biological system. Of course, when I'm done, I'm going to save my work, as always. Saving my project to the cloud. Yay, all done. Okay, so this is project 5 or assignment 5, biological systems.